Hi, in this video, we're going to do a quick review of simplifying radicals. So if we've got a number that we want to square root, but it doesn't square root nicely, what we want to do is we want to break it up into something we can square root and something that we can't in order to get a more simplified version of our original thing. So if I'm looking at 540, I know I can divide 540 by 9. So I could break this square root up into the square root of 9 and the square root of 60. And the reason that I like that is the square root of 9, hey, that's just 3. The square root of 60, I don't know. But I actually know something else about the square root of 60. I can divide 60 by 4, just like I could have divided this 540 by 9. So I could simplify this a little bit more. So I could say that this is the square root of 4 times the square root of 15. What I could have done, now that I kind of know that there were two things I could have done, I could have earlier broken this up into the square root of 36 and the square root of 15, and I'd get the same answer I'm about to get, but I just missed that. And that's okay. You just want to say, hey, I know I can do 9, so do 9, and then see if you can do anything after. So this is 3 times the square root of 4. The square root of 4 is 2, so that's the square root of 6. 6 square roots of 15. I get the same thing over here. 6 square roots of 15. Now, another thing that's true about radicals is we're not allowed to leave square roots in the denominator because they're things that are not rational and they're kind of in the fraction if they're in the denominator. So to get them out, we don't square them away. What we do is we multiply top and bottom by that square root, and that gets rid of the radical for us. Sometimes they'll cancel out, like right here, and sometimes they don't. It's okay. So I want to multiply top and bottom by the square root of 3. So then I end up with 45 square roots of 3 over the square root of 3 times the square root of 3 is just 3. Think about it, it's like the square root of 9 if you put those two square roots together, and the square root of 9 is 3. But then you're saying, hey, 45 divided by 3, we can do that. 45 divided by 3 is 15, and the square root of 3 is just going to sit there on the end. So that is our answer, 15 square roots of 3. Now, the final place that I want to talk about square roots that show up quite often is this thing, the geometric mean. The geometric mean is the square root of the product of two numbers. So it's just taking two numbers, you multiply them together, and you square root them. Where they kind of come into play is if you've got a proportion where both of these values are x, rather than doing any sort of like solving stuff, you can say x is just the geometric mean of a and b. And that just solves the whole proportion right here for you. So if I was looking at this one, if I wanted the geometric mean of those numbers, I would do the square root of 3 times 48. Now, keeping in mind, my goal is to kind of like simplify that down. I could multiply 3 times 48 together. I'd get some huge number. But the other thing I'm kind of thinking about is like, hey, 48 is 3 times 16. So that's a 3 times 16 times another 3 inside of a square root. Well, if I simplified that, that's really just the square root of 9 times the square root of 16. Hey, that's just 3 times 4. So my answer is just 12. I'd get the same answer if I multiplied that 3 and 48 together and then square rooted, but hey, I just was able to do that in my head without a calculator. So that's kind of cool. Either way works, doesn't matter what you want to do. 7 times 9. I want to find the geometric mean. So that's going to be the square root of 7 times 9. Again, I could multiply these two together, but if I wanted to simplify it, hey, I know what the square root of 9 is. That's just 3. And the square root of 7 I can't do. So I can say this is 3 and a square root of 7. Now, when we write our answers, this is kind of considered mathematically rude. It's not wrong, but I don't know right now if the 3 is in the square root or not. It's not. So it's more polite to put the square root at the very end to get your answer. Now this last one, I got to do the square root of 8 and the square root of 12, and I want to do the geometric mean of them. So that means I got to multiply the square root of 8 times the square root of 2, but then for that geometric mean, that means I got to square root all of that again. They're already in square roots, but geometric mean says do their product, that's the red bit, and square root them. So I had to do both things. Well, the square root of 8 and the square root of 2, if those are both radicals, we could put those together, so we get the square root of 16. Don't forget, then there's another square root over all that. But hey, I know what the square root of 16 is. That's 4. And then there's still this brown square root sitting over all that stuff, and I can do the square root of 4. That is 2. There it is, 2. Square root of 4 is 2. And that's it for this video. Remember, if you're simplifying a radical, your goal is to break it up into something you can square root and something that you cannot. And then if you're rationalizing a denominator, you got a square root in the denominator, you want to multiply top and bottom by whatever was in that denominator. Sometimes it goes away, sometimes it just sits kind of like that. Mine went away, but sometimes yours won't, and that's okay. Thanks for watching. Bye-bye.